In previous video we can analyze the report and we can create report cooling load calculation. So now, as you know, that we have 4 zones. So the first zone is we have zone number 1, which is this is our zone 1. So here you see this is zone number 1. Now first of all we can analyze zone 1 report. So this is our zone load summary. So from here we can analyze cooling load summary. This is a heating load summary. So first of all we can select zone 1. From here you can select zone 1, and now we can analyze our cooling load. So first of all, here you say see condition at time. This is a peak time. So the peak time is set 21 July. So at 21 July we have at 5 p.m. at 3 o'clock, approximately 3 o'clock. At 7 July at 3 o'clock we calculate the peak load condition. So what are the outside condition? The dry bulb temperature is 3 centigrade, humidity ratio is 18, wet bulb is 30 centigrade. Similarly, dry bulb temperature is 21 of this for this zone 21, humidity ratio, and relative humidity is, here you see what is relative humidity. The relative humidity is 56. These are zone condition. In zone 21 centigrade, relative humidity is 56, and these are outside environment condition, atmosphere condition. So these are condition of these zones. So now we can remove all heat. So in load calculation we calculate how much heat at this peak time. So this heat, now we can capacity per floor engineering checks. We have capacity per floor area. This is 178.82 watt per meter cube. Floor area per capacity, outdoor air percentage is 38.5. Air flow per floor area is this 0.015 meter cube per second meter. Airflow capacity is this 0.000 and 0.89. Number of people at this complete zone is 34. So these are all data. Now here this is cooling load. So the envelope mean roof. The heat this is the total heat that come from building envelope. Building envelope mean the here you see in space. Building envelope mean the heat that's come through these walls, through these external walls, from these partition wall, from roof, from floor. So this is all building envelope. So now we from roof you delete we have different type of heat. One is instant sensible. Instant sensible means that heat produce light immediately, like you can on your electronic device, it produce heat. This is an instant sensible heat load. So delayed sensible mean that the radiation come from outside, like when the sun radiation falls on the external wall of then it takes some time to transform from external wall to internal spaces. So this is delayed load. Similarly, we have latent load, and this is a total load, sum of instant, delayed and latent load. So we have from roof we have delayed load of 56 watt. Similarly, from ceiling we have delayed sensible heat of 504 watt. So total is also 504 watt. Similarly, through door 599 watt load watt heat is transferred. Similarly, from wall 1633 watt wall, it is transferred at 3 o'clock at 21 July. Similarly, through partition 186 watt heat is transferred. From slab 476 watt heat is transferred. Similarly, we can add all these heat. The total heat that transfer from outside environment to indoor through building envelope is 5889 watt. Similarly, internal gain means that the heat produced within the zone, like as a people we generate heat, so how much heat generated by people, how much heat generated by light, how much heat is generated by return air, how much light, how much heat that equipment generated. So people generate total 18,060 watt heat, which is sensible heat, 5,706 watt, this is delayed sensible, 15,835 watt latent heat. So the total heat that people are generated by 39,601, this is watt in watt, which means that it's 3.9 kilowatt, 39 kilowatt. So from light 8.1 kilowatt heat is generated by sensible, and total is 8.1. Similarly, return air produce zero light, zero heat, equipment produce 4,807 sensible heat, which means 4.8 kilowatt. Similarly, from zone ventilation, 29 kilowatt heat is generated, and 1.9 kilowatt heat is also latent. So total heat is 27 kilowatt. Similarly, the total heat generated by complete zone is 85 kilowatt. So here you see this is peak load. The peak cooling load is 85.554 kilowatt, or 85,554 watt. So this is the total peak cooling load. So now similarly we have other heating side. So we will analyze our heating report. So condition peak time, the condition is 21 January. So the peak cooling condition is at 21 July, and it's at 24 o'clock, which means at 24 o'clock. Okay, and the outside condition is the outside temperature, dry bulb temperature is 3 centigrade, humidity ratio is -1. Similarly, wet bulb temperature is -1.9 centigrade, and the internal zone conditions are that dry bulb temperature is 21.1, humidity ratio is 0.0042, and relative humidity is 27.2. So humidity ratio is also very low. So these are all engineering checks, so we can analyze report. From roof, the heat as you know that the internal space has 21 centigrade, so the heat go away from the room, so that is -86. 21, this is a condition that we maintain in the room in dry bulb. So we can from roof, the heat transfer from indoor to outdoor environment is -86. In ceiling, through ceiling, 381 watt heat go away from the spaces and from the zone. Similarly, from door, the 441 watt heat is moved from internal space to external. Similarly, we lost through wall 2167 watt heat is lost. So the total heat lost through building envelope is 14 kilowatt. Similarly, the total internal heat gain is 0. Similarly, the total heat loss through zone ventilation is approximately 76,000. So how much heating we required is 91.4 kilowatt. We know we require 91.4 kilowatt heaters or heaters for heating in winter. So similarly we have other, we can also analyze other reports during designing on the basis of these load condition. In these loads we place equipment.